Hi everyone and welcome to another lesson for N001 Earth Science. For Module 6, we will talk about minerals. At the end of the lesson, you are expected to first, describe how our minerals are found, mined, and processed for human use. Next, identify common rock-forming minerals using their physical and chemical properties. And lastly, identify the minerals important to society. But first, let's think about what is the difference between rocks and minerals. The Earth's crust consists of different types of rocks and minerals. And to understand rocks essentially, we must first learn about minerals. Minerals are the building blocks of rocks. They are solid and naturally occurring inorganic crystalline material characterized by a particular chemical formula and an ordered structure within. Minerals can form real crystals. The word crystal derived from the ancient Greek word krystallos, meaning ice, and rock crystal. A crystal is a geometric shape visible to the naked eye consisting of smooth faces and sharp edges. Examples of these include diamond, salt, quartz, and snowflakes. Every mineral is unique, however, they still exhibit a general characteristic, such as minerals are naturally occurring. They exist upon natural processes. Minerals are inorganic. They are limited to substances formed through inorganic processes, which are activities that living things cannot carry out. Minerals are solid. They cannot be liquids or gases. They exist only as solids, which is a state of matter that possesses a high amount of order. Next, minerals have definite chemical compositions. The chemical composition of minerals should express the exact chemical formula with the elements and compounds in specific ratios. And lastly, minerals have ordered internal structure. The atoms in minerals are organized in a regular repetitive geometric patterns or also described as the crystal structure. So how are minerals formed? The formation of minerals is affected by factors such as temperature, time, pressure, and concentration and availability of charged particles in solution. Minerals can grow from solids and gases under the right conditions. Nevertheless, minerals are also formed in water solutions or magma. Minerals and crystals can form from magma and lava. Minerals from hot magma as it cools inside the crust is called intrusive cooling. And as lava cools on the surface, it is called extrusive cooling. When these liquids cool to a solid, they form crystals and minerals. The size of the crystal or mineral depends on the amount of water present and time it takes for it to solidify. For large crystals, they are the result of a slow cooling process or high water content, while for small or even microscopic crystals are the result from rapid cooling process or presence of a small volume of water. For intrusive cooling, they are considered as slow cooling, which has small crystals. For extrusive cooling, they are considered as rapid cooling with large crystals. Next, minerals and crystals formed by evaporation. Minerals can form when solution or mixture evaporates. For example, salt crystals are formed by the evaporation of salt water. As salt water evaporates, it leaves behind the salt, allowing its chemical energy to take over and form crystals. The longer the evaporation lasts, the bigger the crystals. Other minerals form from evaporation too, depending on the substances dissolved in the water. Each of the nearly 4,000 minerals Earth has is a special material identified by its chemical composition and internal structure. The chemical properties of minerals show the presence and arrangement of mineral atoms. The chemical bonds hold together the atoms and molecules which make up a mineral. The strength and composition of such bonds affects the resistance and hardness of the minerals it creates. In terms of composition, minerals can be classified into several mineral classes which are mainly composed of elements that are abundant on Earth's crust. The first one is called silicates. Silicates is the largest group composed primarily of silicon-oxygen tetrahedrons. Next is called oxides. It contains oxygen that is combined with one or more metals. Sulfides consist of metal cation bonded to a sulfide, while sulfates consist of a metal anion bonded to a sulfate. Halides contains natural salts and are composed of a halogen ion. Carbonates are characterized by the presence of carbonic ion. And lastly, native metals consist of a single metal such as copper and gold. Now let's talk about the physical properties of minerals. The first one is called the crystal structure. It is defined as the orderly, geometric spatial arrangement of an atom in a mineral's internal structure. Minerals with identical chemical composition also share the same structure and usually belong to the same group. These are the 6 crystal systems used in grouping minerals. The first one we have triclinic, monoclinic, orthorhombic, tetragonal, hexagonal, and isometric structures. Next is crystal habit, which refers to the overall shape of a crystal. If a crystal is allowed to grow in an unrestricted environment, it develops natural crystal faces and assumes a specific geometric crystal form. Common shapes include acicular, which are needle-like, dendritic, which are plant-like, reniform, which are kidney-shaped, and prismatic. The hardness of a mineral is a measurement of the strength of the chemical bonds in its structure. It also refers to the mineral's resistance to scratch. The Mohs scale of hardness is the most common scale of measurement when it comes to a mineral hardness. The mineral with the highest index scratch minerals below it, and as you can see, diamond is considered as the hardest mineral. Next is color and streak. Color refers to the hue of the mineral seen by the naked eye, while streak refers to the color of the mineral in its powdered form. In order to obtain the streak, a streak test is performed by rubbing the mineral on an abrasive ceramic tile. Transparency and luster. Transparency refers to the ability of the mineral to allow light to pass through. It is considered opaque if the light cannot pass, translucent if light is transmitted with distortion, and transparent if light is transmitted freely without distortion, while luster describes the appearance of light reflected from the surface of the mineral. Examples are metallic, vitreous, which are glass-like, resinous, and non-metallic, which are pearly, dull, greasy, and silky. And lastly is cleavage. Cleavage refers to the mineral's resistance to being broken and is used to describe how minerals break into pieces. Breakage of minerals may take place in weak parts of the structure, Thus, it is called cleavage. When a mineral breaks in a direction where there is no cleavage, it is called a fracture. The mineral is then completely broken or crushed. This table shows the examples of common minerals and their uses. Dietary minerals and human nutrition. There are 6 essential substances you cannot live without. These nutrients are chemical substances that come from food that we eat, such as macro and micronutrients and water. Macronutrients include protein, fats, and carbohydrates, which are required in large amounts, while micronutrients include vitamins and dietary minerals, which are required in small amounts, while water serves as the carrier in distributing nutrients to cells and removing waste through urine. Dietary minerals are chemical elements required by living organisms, and it can be further grouped into two, which are macro and micro minerals. Macro minerals includes phosphorus, calcium, sodium, potassium, and iron. They have multiple roles in the body and are obtained in different resources. For micromineral, we have iodine, zinc, fluoride, and chromium. Just like macro minerals, they have several functions in the body that comes from different resources. A mineral resource is a concentration of naturally occurring material from the Earth's crust that we can extract and process into raw materials and useful products at an affordable cost. There are two major types of minerals: metallic minerals and non-metallic minerals. Metallic minerals, as the name suggests, contains one or more metals. There are good heat and electricity conductor. In nature, they are malleable and ductile. You can easily pound it into thin sheets or stretch it into wires to produce new products. Metallic minerals are generally found in igneous rock, which are formed by cooling and solidification of lava or magma. And metallic minerals are categorized into two, which are ferrous and non-ferrous minerals. Ferrous minerals contains iron, while non-ferrous minerals doesn't. Non-metallic minerals are minerals that do not contain metals. They are used in various industries for manufacturing of a variety of products, such as aluminum. Aluminum is used in food and soda canisters. They are also used in the manufacture of fertilizers and in refractory processing. An ore is a solid deposit in Earth's crust of one or more valuable mineral, often a metal, to make it profitable for mining and processing. It can either be a high-grade or a low-grade ore. A high-grade ore contains a high concentration of the desired mineral, while the low-grade ore has a lower concentration. The quality of the ore, the density of a rock or metal ore, and its form of occurrence will directly affect the cost of mining the ore. Therefore, the production cost must be measured against the metal value found in the rock to decide which ore can be extracted or which ore is a low grade to be worth mining. In this picture is an example of the most important ore of aluminum, which is bauxite. There are different ways of locating ores. Number 1, we have hydrothermal fluid circulation, which is the most common type of ore mineral deposition process. Hydrothermal fluids are natural heated water solutions, which are usually groundwater or seawater, wherein elements, compounds, and gases may dissolve. Next, we have metamorphic processes, which are a result of mineral alteration and recrystallization, which assist in the production and localization of commercially valuable products. Next, we have magmatic processes, which create ore minerals that is concentrated due to their premature crystallization and separation from magma. Kimberlite magma is a type of magma that originates deep within the mantle and is the source of diamonds, which only crystallizes at depths greater than 150 kilometers. Their passage through the crust and eventual solidification leaves behind highly prized diamond ores, while chemical sedimentary processes form evaporates deposit from the precipitation of saltwater minerals. Sediments continue to carry up the motion of currents in moving surface water. If the action and intensity of the wave is constant, it causes a selective sifting effect which removes sediments and leaves behind those which are heavier in what they are called as placer deposits. And lastly, chemical weathering occurs when rocks are exposed to oxygen and water, which causes chemical changes in their mineral components that result in their alteration into other minerals and into the formation of residual ore deposits. Mining refers to the process of extracting useful minerals from the surface of the earth, including the seas. Mining ores is an extensive and complex operation that varies depending on the mineral and whether it is excavated, stripped, or transported via tunnels and shafts. In general, the following steps are done during mining. The first one is prospecting or exploration. It requires geological expertise in the detection of areas where a particular mineral may be found. It is done by looking for the ore body solely on the examination of deposits found on or near the surface. Next is drilling. It is extracting a part of the ore where core samples are collected for the purpose of evaluating the grade and weight of deposits. Modeling is detecting the scale, shape, and grade of the ore in the deposit to apply correct mining methods, design of blasting and digging patterns, safety measures, and production and processing procedures. Next is identifying and assessing the potential impacts. It is the consideration of social and environmental issues and seeking ways to minimize the effects of the mining activity. Designing and constructing the mine is the creation of the suitable mine and operational design and construction work once all relevant permits have been obtained from the government and local communities. This process calls for the use of studies that help determine whether the project is safe, socially responsible, environmentally sustainable, and economically viable. Next is ore extraction. It is the separation of high-grade ores from the rest of the deposit. Milling is the crushing and concentration of ores. Waste materials are released. And lastly, the mine site decommissioning. It is the closure of the depleted mine. And that's it for today's lesson, class. Thank you so much for listening and watching with me. Remember to keep safe and study hard.
Happy learning at home with lessons made easy by Olivarian GoTeach. One proud Olivarian.